Um, all right, welcome. This is the Group 20 presentation for CMPT470. Today we're going to introduce Java Spring. So let's get into it. What's Spring? In Java, Spring is an open source design level framework. It solves the loose coupling between the business logic layer and other layers. Therefore, it applies interface-oriented program ideas throughout the entire system application. Simply put, Spring is a layered Java full-stack, lightweight, open-source framework. In the book Expert 101 Java 2 Platform Enterprise Edition Design and Developments, edited by Ron Johnson in 2002, he questioned that status quo of the Java Enterprise Edition system frameworks as bloated, inefficient, and divorced from the realities, and actively thought to explore innovations ways. Later, he created Interface 21 framework, which is lightweight development frameworks that tries to break through the traditional developments of Java to Platform Enterprise Edition. The Spring framework is based on the Interface 21 framework. After redesigning and continuously enriching its connotations, the 1.0 official version was released on March 24, 2004. Spring has been filled since its birth, and the reason can be briefly summarized as the following. The first is secure. Spring provides an easy and secure way to handle forms, logins, and self. It has a proven track record of dealing with security issues quickly and responsibly. The Spring committers works with security professionals to patch and test any reported vulnerabilities. Third-party dependencies are also monitored closely, and the regular updates are issued to help keep data and applications as safe as possible. The second is flexible. Spring is flexible and a comprehensive set of extensions and third-party libraries let developers build almost any applications imaginable. At its core, Spring Framework's inversion control and dependencies injections features provide the foundation for the wide-ranging set of features and functionality. Spring takes care of all of the dependencies you might want or need to build all your kind and apps, and it can help you whether you are building microservices for web or complex streaming data flows for the enterprise. It could be a nightmare when you have to build a complex web app using Java, but Spring handles all while exceptionally well. Spring Boot combines necessities such as application context and auto-configures embedded web servers to make microservice developers cinch. It transfers how you approach Java programming tasks, radically streamlining your experience. Lastly, Spring also performs well in performance. With Spring, you will notice faster startup, faster shutdown, and optimized execution by default. Increasingly, Spring projects also support the reactive program mode for even greater efficiency. Spring Boot helps developers build applications with ease. Its abundant web servers, auto-configuration, and Farjars help you get started quickly. And innovations like leaf reloads in Spring development tools means developers can iterate faster. Now, we have the basic knowledge of Spring. Next, let's move further into the details.
Now let's talk about the special features of Java Spring, the inverse of control and aspect-oriented programming. The first one is the inverse of control. The inverse of control is not a technique, it's more like a thought. It inverts the flow of control as compared to the traditional control flow. The traditional coding style cannot adapt to the changes in user requirements, requiring the programmers to manually create new class to meet user needs. If we have a huge amount of code volume, then making change to meet user requirements will be super expensive, needs endless repetitive work. So the inverse of control was invented to solve this problem. In the past, we create a new object by calling a new statement, like here the new statement, but now we choose to use set injection. Then the program will create objects according to what user passed to it. In this way, the initiative of object creation will be inverted from programmers to users. That's the concept of IOC. Uh, and in Java Spring, IOC is implemented by dependency injection, like we saw here. Dependency injection has three parts. The client class, the service class, and injector class. So what is dependency? The client class depends on the service class, and the service class provides object to client class. We say they are high coupling. This makes coding more complicated, so we want to decouple their dependency. This comes with the third class, the injector class, which refers to IOC containers in Java Spring. The injector class takes information from the service class and create objects and inject it to the client class. The client class depends on the object injection of the injector class, and the service class depends on the object creation of the injector class. This is the dependency part. And the injector class inject informations to REST classes is the injection part. In Java Spring, there are two dependency injection method, which are refers to the setter dependency injection and the constructor dependency injection. Like we saw here, this part is the setter injection. It's a set method and the constructor injection. Nowadays, this architecture is used everywhere in our lives. Whenever a program can let user choose the theme or model they like, that should be an IOC architecture. There are three advantages of this architecture. It can decoupling the execution of a task from its implementation and making it easier to switch between different implementations and have more focus on business implementation. So now let's talk about the second special feature, the aspect-oriented programming. This is a programming paradigm that aims to increase modularity by allowing the separation of cross-cutting concerns. It does this by adding additional behaviors to existing code without modifying the code itself. This is done by inserting several aspects to the code through advice to join points, which satisfy some point cuts, like we showed here. The join points could be refers to the object we create in our code. The point cut refers to some conditions that can be satisfied by parts of object. And the advice could be refers to the perform on the join points that satisfy some point cuts. And join points, point cuts, and advice are combined to be called an aspect. This makes sure that we can add new method or functions to the current code without changing any original code. But it only has one disadvantage, that object and aspect are in one-to-one relations. Developers should write new aspect for each object when new methods are needed. This comes with double code implementation.
Next part is about what makes Spring cool. We found two cool things in Java Spring. Firstly, Spring has an MVC framework called Spring MVC. In addition, Spring has Pojo implementation. Now, let's talk about Spring MVC first. Spring MVC is a Java framework that is used to build web applications. It follows the model view controller design pattern. Just briefly introduce what MVC is. MVC divides a project into three parts, including views, controllers, and models. The model defines the application business layer. The controller manages the flow of the application, and the view defines the application's presentation layer. The separation makes multiple views able to share the same model. It improved code reusability. Since the three parts of the MVC model are independent, changing one will not affect the other two. What's the difference between them? How does Spring MVC help Java web development? Spring MVC is also an MVC framework. The main difference between them is Spring MVC extends the MVC framework to include more layers. We can see the two images below. We can see Spring MVC contains a firm controller, which the base MVC doesn't contain. In base MVC, we have multiple controllers. These controllers are simple Java classes. Different controllers handles the different requests. We have to use some hard code to establish the mapping. It increases our workload. In Spring MVC, all controllers are annotated with two pieces of information, a URL and an HTTP message. How does the firm controller work? When a user's request comes in, it is accepted by the firm controller. This acts as the main controller and passes the request to the relevant controller based on the request mappings and HTTP message. Because all the controllers are annotated with a URL and HTTP method, the firm controller can map the URL and the HTTP of the request to the relevant controller. And then a particular method will be executed. Now we come to the second cool thing, POJO. Spring Framework has POJO implementation. What is POJO? POJO means plain old Java object. It has three rules. First, can't extend anything. Second, can't implement anything. Third, no outside annotations. It just means a simple class without extra stuff that can be used by itself. All classes in the model layer has to be POJO classes. So, our domain logic code generally has no dependency on the framework itself. Since all logic codes has no dependencies on the framework, you can easily reuse them in other applications without using the Spring framework. POJO makes Java Spring non-intrusive.
Spring is the framework of choice to wire enterprise Java applications. It has solved a number of problems that enterprise Java applications has faced. Seems the complicated associated with EJB2. A few of them are here. Firstly, Spring takes loss coupling between classes by dependency injection. While loss coupling is beneficial to application maintainability in the long run, the first benefits are realized with the testability that brings in. If objects are widely using Spring, writing unit tests becomes easier. We can easily sub or merge dependency and write them into objects. For the second one, programmer has to perform a Java naming and directory interface lookup, get a connection and populate the results before. It resulted in duplicate code. One of those problems Spring solved was by cleaning up old plumbing code. With Spring JDBC, Spring JMS, and other abstractions, the developer could focus on writing business logic. And then, using EJBs make applications complex. And not all applications needed complexity. So Spring provided a simplified, lightweight way of developing applications. If the distribution was needed, it can be added later. In spite of its ever-looming presence, Spring did not restrict the flexibility or choice of the frameworks that application architects or developers had. For example, Spring's framework provided great flexibility in the web layer. We have the choice of integrating with a wide range of view and template frameworks. When Spring framework is used to manage beans, the Spring IOC container manages the lifecycle, creation, use, auto-reviving, and extraction of the beans. It makes it easier to weave addiction functionality around the beans. Spring encouraged the use of a number of disciplines by default. A few examples are as follows. 1. Dependency injection or inversion of controller. This is the fundamental design plan the Spring Framework is to build to enable. This enables loss coupling and testability. Second one, singleton. All Spring beans are singletons by default. 3. Factory pendant. Using the bean factory to instantiate beans is a good example of the factory pendant. 4. Front controller. Spring MVC use the dispatch service as front controller. 5. Template methods helps us to avoid boilerplate code. Many Spring-based classes, JDBC template and JMS template, are implementation of this pattern.
That brings us to the end of the presentation. I would like to summarize by saying Spring provides better leverage with each line of the code written where you know, and you can handle each line which is faster and requires less maintenance. Nowadays, its lightweight, dexterous, easy to develop, and easy to test the features makes Spring widely used. Simply put, using Spring is to make life easier for Java web development. Thank you so much for your interest and attention.